I think Math Olympiads is something that's been really, really special to me for forever. I remember I was starting off in like 7th grade or something, and it was just something that I found interesting. It was something that I got a little bit of thrill of. I was just trying to do my best, but today I am the director of the Sophie Fellowship.
Wonderful.
And now I think the stage has come where I'm also sort of retiring from the director and someone else from the team is taking
You're
over.
retiring at 17.
Like the general, this thing is once people go to college, they give it to the next generation. And
Right. Did you write the JEE exam?
No, I didn't write the JEE exam, but I was preparing for it actually. I took the sort of in between where I said, okay, I will prepare for JEE, but I will also prepare for Math Olympiads. Math of JEE is a lot more about speed. It's about getting the answer fast. It doesn't even matter what methods you use. You could be like just guessing the answer or something. There's a lot of formulas and stuff involved. And then this is the first problem. And I'm like, huh? Like remainders. I thought the only way you can do them is long division.
Right.
Surely you don't expect me to calculate 111 raised to 111. Yeah, and then I showed it to my dad and he was also like, huh, okay, interesting. And you want to divide this by 13. And you just want the remainder. You don't really care about the quotient. Basic method to find the sort of remainder would be to actually do the long division and like evaluate the thing. But of course we can't do that here. Instead, we're looking at some sort of new way. And the way I like to explain this, you change entire mathematics. So you change the way math works.
Namo. Right now I have with me the flag bearer of India's spectacular performance at the 65th International Mathematical Olympiad, Rushil Mathur from our very own Mumbai, from Amchi, Mumbai. Rushil is a math enthusiast. He has currently cleared his 12th standard examinations and he is off to Oxford University for an undergraduate degree in mathematics and computer science. He loves to play the piano. He loves to play bullet chess. I'm sure he can beat me in 10 seconds. And he is the youngest guest of our show. So Rushil Mathur, congratulations and welcome to the show.
Thank you so much.
So, we'll speak in English or Hindi?
English is...
Okay. You represented the country at the International Mathematical Olympiad and you won a gold medal. You helped India achieve our best ever performance at the Mathematical Olympiads. How does it feel?
Yeah, I think it's like sort of a surreal feeling. Like 1 year back, I was not really expecting that this day would be like this. I think Math Olympiads is something that's been really, really special to me for forever. I remember I was starting off in like 7th grade or something, and it was just something that I found interesting. It was something that I got a little bit of thrill of, because when I started seeing some of these problems, I just had no idea how to approach them. I was like confused. So I was like, if there are these sorts of problems which, you know, I can't really solve, and then you sort of learn these new tricks and ideas, that sort of gave me a thrill, this sort of thrill of solving problems. And that's what, you know, got me into Math Olympiads. And today, like, to reach this stage, to have represented India at IMO and even having won a gold medal.
This was your debut at IMO, right?
Yeah. So I was not expecting to win a gold medal. I was just trying to do my best. But yeah, I think it was really an amazing experience, a sort of surreal feeling to finally be there. And yeah, I'm very honored.
Great. How did you prepare for this competition, which is the most prestigious competition in mathematics for pre-university students? So how did you prepare mentally, mathematically? How was it like?
It's not really about, you know, a month or a few months. It's about years. So I think it really started off when I started preparing in 8th grade for this, you know, sort of regional math Olympiad, etc. And I had a lot of setbacks. Back in 8th grade, I missed out on qualifying for our national Olympiad based on a tie break. So I had the same score as what was needed, but then there were some tie breaks, and they just like, there were 3 people who missed out, and one of them was me.
When was this?
This was back when I was in 8th grade.
4 years ago.
Yeah. So that was quite heartbreaking, and I honestly stopped doing Math Olympiads for a while. I didn't know whether I was going to get back into them. I didn't have that much of an attachment to it. It was just something I found interesting. And I think what brought me back is not the sort of feeling that I want to take revenge or I want to, you know, get back. It was just like I really enjoyed doing those problems. So I didn't really care anymore about whether I did well, whether I didn't. It was just about like enjoying the sort of process of solving problems. And that's what's been keeping me going. So in 9th, I managed to get some sort of a merit awardee at the National Olympiad, which is like top 75 in India. And I think that's when I, got introduced to a lot of different things. I think one of the most important things that's happened in India over the past few years is there are a lot of new programs that are being run by past students themselves. So one of them was the SOFI Fellowship, which was run for basically around 20 to 25 students who were selected from across the country. And they're trained over the course of the year. And this is very important because you can't really train students over a month for something like this. It has to be over the year. It's a slow process because you have to solve a lot of problems, you have to practice a lot. So it takes time, but this sort of program was very important, and it was being run by people who were barely 3-4 years older than me. In fact, one of them was our observer this year at the IMO, Rohan. And another one was Pranjal, who is a 3-time IMO Gold medalist from India. So
Pranjal Srivastav.
Yeah. So these people were like the sort of opportunity to interact with them, be in a class with them, when your dream is to be at the IMO and they're people who have sort of accomplished these things. That sort of makes you feel like, okay, they're no gods. If they can do it, maybe you can do it as well. And just to, get a little bit into today, I am the director of the SOFI Fellowship.
Wonderful.
And now I think the stage has come where I'm also sort of retiring from the director and someone else from the team is taking
You're
over.
retiring at 17.
Like this thing is once people go to college, they give it to the next generation. And
Right.
So I think someone younger from our own IMO team is taking over, and it's an interesting journey. So I think the SOFI Fellowship was really something that brought me this whole community. I started interacting with 20-25 other math enthusiasts and also these sort of people who had prepared in the past. And I think this really made me feel like, until then I'd been doing math on my own. But when you start realizing that there are other people who are just like you and who are just as interested, that gives you a lot of more opportunities to solve problems together, to have fun together. And I think that's what really made it clear to me that, okay, Math Olympiad is something I really want to do. It's not just some hobby. Then 11th grade started and I had now cleared the National Olympiad, so I qualified for the camp, but I had not been able to make it to the team. And at the start of 11, there were a lot of people who were telling me that, okay, stop Math Olympiad now. It's time to do JEE. It's time to do this. But
did you write the JEE exam?
No, I didn't write the JEE exam, but I was preparing for it actually. So I took this sort of in between where I said, okay, I will prepare for JEE, but I will also prepare for Math Olympiads. And that was actually
How were your team members? Did they write JEE?
No.
None of them?
None of them have written JEE. One of them wrote JEE mains,
I see.
but then they didn't bother with advanced.
I see.
I think the reason broadly is that if you look at physics and chemistry, you'll find a very large intersection because the physics and chemistry Olympiads, their topics are somewhat close enough to the physics and chemistry of JEE. But the maths of JEE is completely different. Math of JEE is a lot more about speed. It's about getting the answer fast. Doesn't even matter what methods you use. You could be like just guessing the answer or something. And also like there's a lot of formulas and stuff involved. Whereas Olympiad math is more like, it doesn't matter if you know 500 formulas. It's about some sort of innovative thinking.
It's a new problem and you have to solve it.
Yeah, exactly. You have no idea, as I said earlier, when you see the problem. It's just something new and you have to use your out of the box sort of thinking and creative thinking to solve the problem in some new way. So I think the preparation has been a long process. I think by the end of 11th, I had reached sort of the epics of preparation. After that, it was mostly just like experience and go through it. I think preparation is not something that happens over a day. A lot of people ask me, how many hours did you prepare? I think that's not the right question. It doesn't matter how many hours you prepare. It matters how long you prepare. These are things people do for a lot of years. Like I think some of our team members have been doing this since 5th grade. I still started in like 7th and 8th. But it does matter sometimes starting early. On the other side, there are people who started late, started in 10th and still made it to the team. But I think just having a long-term dedication towards mathematics is very important.
Great. How and when did you find that maths is for you? How did you find your calling, and when was this?
Honestly, I'm not 100% certain math is for me even today. But if I was to answer, let's say when Math Olympiads was my true calling, it was probably when I started getting into these Sophie Fellowship programs and things like that, because I found a peer group, I found people I could relate with, and people who had done what I did and had been very successful. So people like Pranjal and stuff who had gotten such good results and had gone to, the top universities of the world.
Where did Pranjal go?
Pranjal went to MIT.
I see. He's studying math there?
He's studying computer science, actually.
Computer science.
Yeah. So, just the feeling of, there are so many people who have done what I've done and they've been very successful. That gave me a lot of confidence. Otherwise, it was mostly a hobby. I had no idea where this would take me. But once I realized that this can be a concrete goal and this should be a concrete goal for me, given how much I enjoy it.
Right.
That's when I realized that, okay, this is something that is special to me.
Right. And did your parents help you with getting into mathematics?
My parents were always 10,000% supportive. They were like, you should do what you want, even when the whole world was like, no, ask him to stop doing math, do JEE, do this, do that. They were like, he wants to do this, let him do this.
Great. Wonderful. I read your interview to the Times of India, where you had mentioned there was one particular problem which aroused your curiosity in the Mathematical Olympiad, and that was what's the remainder when 111 raised to 111 is divided by 13? So if you could tell us about that moment and maybe take a moment to show our viewers how do you do that?
Yeah, so first just a little bit of a story. Like this was around the time I first prepared for this local math competition. It was Junior Maths Olympiad. It's conducted in Mumbai only. And they had this past paper and I'd qualified for the second level and I was like, okay, what are the problems? And then this is the first problem. And I'm like, huh? Remainders. I thought the only way you can do them is long division. Right. Surely you don't expect me to calculate 111 raised to 111. Like I can't even do 111 cubed. And then I showed it to my dad and he was also like, huh, okay, interesting. But then he came up with this sort of idea based on he had seen some sort of similar problems in the past. And he told me, okay, there's this sort of thing. And then we saw some YouTube videos and we started figuring out, okay, there's this, thing called modular arithmetic. And that's what really helped us. Eventually, after like a week of just thinking about the problem, we finally got to a point, okay, this is the solution.
So it was father and you together solving it.
Yeah.
Great.
Yeah.
Wonderful.
So if I'm to just write.
Yeah. So if you could please show our viewers how to solve it on this whiteboard, please.
So the question in the Olympiad was something like you have 111 raised to 111 and you want to divide this by 13 and you just want the remainder. You don't really care about the quotient. So, the basic method to find this sort of remainder would be to actually do the long division and like evaluate the thing. But of course we can't do that here. So instead, we're looking at some sort of new way. And the way I like to explain this is that you change entire mathematics. So you change the way math works in terms of, we're all used to seeing a number line. But instead, think of a number circle. So let's say there's a 0 here, there's a 1 here, there's a 2 here, and so on. So there's a 12 here, and then 13 somehow comes back to 0. So this is basically how remainders work. Like 13 is the same as 0 if you're looking at the remainder when divided by 13. 14 is the same as 1. 15 is the same as 2 and so on. So really when you're looking at the remainder when divided by 13, your world really needs to have only 13 numbers. So now there are very different sort of equalities. So the way we do this is something like A congruent to B, which is really saying that in this world of number circles, these two numbers are the same. So for example, I can say that 14 is congruent to 1 in this world of 13. So it's called 14 congruent to 1 mod 13. And in this new world, you can create a lot of rules. So you get something like, for example, if A is congruent to B and C is congruent to D, then their sums will be congruent. So A plus C will be congruent to B plus D. Or A into C will be congruent to B into D. And the proofs of these are mostly not very involved. Like The point is just that 13 will divide their difference, and so you just define a equal b plus 13 times some constant, and you work out some algebra. But what really works out very interestingly is now, since we know that, for example, 111 we can rewrite as 111 is something like 104 plus 7. 104 is divisible by 13. So really in this world, 111 is the same as 7. So 111 to the 111 in this new world is same as 7 to the 111. So that already like reduces work by a fair bit. But still, this is a huge number. So the way we work around this is, for example, let's evaluate 7 square mod 13. 7 square we know is 49, but 49 itself becomes 10 because 39 is divisible. So like 10 plus 39 is 49 and 39 is 0. So it's really like 10. So if you're looking at 111 square, these are all equal. And if you cube this one more time, so if you do this whole cubed, then you get 1000 over here. And the interesting thing, which the reason I did this is, the lucky thing is that 1000 is actually equal to minus 1. And this is interesting. Okay, we're not supposed to do minus 1 over here. Like it's supposed to be a number from 0 to 12, but we can do that too. We can get into negative numbers. 12 is really the same as minus 1. Like it's like you can go backwards as well.
So 1001 is divisible by 13.
Exactly. That's the key fact we use. 1001 is, I think, 7 into 11 into 13. So 1000 is minus 1. So you can get 111 raised to 6 will be minus 1. And in particular, 111 raised to 12 will be minus 1 squared, which is 1. So 111 raised to 12 is 1 mod 13. And in fact, this is a consequence of this theorem called Fermat's little theorem, which says that regardless of what number you took here, any number raised to 12 will be 1 mod 13. 13, of course, it's like p minus 1 where p is a prime. But the interesting thing is now, because you know this, you can exponentiate this to, let's say, the 9th power, and 12 into 9 becomes 108. So now you know 111 to the 108 is 1 mod 13. And all that's really left now is 111 cubed mod 13, and okay, that can be evaluated in a similar way. Yeah, 7 cubed, that's 343. So 343 comes down to, I think, 5 mod 13.
Or you could do 7 square into 7. So you could do...
Yeah, 10 into 7. So that's even faster. That becomes 10 into 7, that's 70. And
that's 5.
That's 5. So you get that the answer is eventually going to be 5 mod 13.
Brilliant. That was great, Rushil. Now, I also want to show our viewers the book that Rushil has authored. It is called An Exploration of Olympiad Combinatorics. As I expected, it is typeset in LaTeX. And it has a set of problems, how to solve them, around 600 hints. Is that right? It's 290 pages long, and all of this is mathematics. So, I think you're not only the youngest guest on our show, you're also the youngest author I've met in my life. When did you write this book? What was the motivation? And how did you get about publishing this?
Yeah, I think it was over, like, let's say the end part of 11th to mid 12th. Like, then the publication.
So just last year?
Yeah, just quite recent. It only got published completely at like 28th April or something this year. So it's quite a recent sort of this thing. I don't think it's a novelty in terms of the fact that people who have done Olympiad math, they sometimes do end up writing these books, because the books I used to study geometry and number theory had actually been written by high school students themselves. So I think that's what sort of gave...
Who were the students?
So the geometry book by was this person called Evan Chen, who is a US math coach. He's now doing his PhD at MIT. And the number theory book was by Aditya Khurmi. He's actually an Indian as well. He is now in the US, and I don't fully recall which university, but yeah, he's also done math Olympiads in the past. Yeah, I think what really led me to writing this book is that, you know, while there were these brilliant books for geometry and number theory, combinatorics was a bit untouched. Like, there were some books, but they were either a bit too advanced or a bit too easy. There was nothing really that covered the basics and reached the sort of level that it should. But really, the biggest thing that led me to write this book is really my passion for teaching, which grew over time. I think, as I mentioned earlier, now I was the director of the Sophie Fellowship. I think this was all really connected to this sort of love for teaching that I've developed over the past year. I've taken over like 100 plus hours of teaching, just one-on-one.
Do you teach on YouTube as well?
Yeah, I do have a lot of classes available on YouTube.
Do you have a channel?
It's not my channel. It's this channel called the Online Math Club.
The Online Math Club, for our viewers, the Online Math Club.
Where there are like a lot of, Math Olympiad students themselves from India who teach. So I have like, I think 13, 14, 1.5 hour sessions there, which are freely available. And I also taught one-on-one in this program called OTIS, Olympiad Training for Individual Studies, where I just selected 3 or 4 students who were preparing for the national and international Olympiads, and I taught them one-on-one for like 3 hours at a stretch. So I think I really enjoyed this sort of process because honestly, like one of the things that led me to getting an IMO medal might have been just this teaching that I did, because it gave me sort of a new sort of experience and a new sort of way of thinking about a lot of different math concepts. And that's also what led me to writing this book. I felt excited about sort of this idea that, I can write a book too, and I can reach a lot of people. And, I'd taken classes on so many of the chapters related to this book. I was like, okay, let's just collect all of my material and put it together in some sense. And yeah, it started off as just, a little bit like a handout. Like I was like, let's write up some things because I felt like some of my classes, I could have written some notes as well for people. And then it reached the stage where it was like 80, 100 pages. So I was like, okay, let's just make it a proper book at this stage.
Right. Interestingly, for our viewers, Combinatorics has an Indian connection. The basic formula for N choose R was given by Mahaviracharya, a 9th century or maybe 8th century Indian mathematician in a Sanskrit text. I have a video on the same on my channel. I'll put a link to that. So Combinatorics, and we've had 2 professors of Combinatorics today, and we have Rushil Mathur, who has a book on Olympiad Combinatorics. So it's a great feeling to have all of them on our show. Moving on, Rushil. So you're going to Oxford now. What are your plans for the future?
I'm not entirely sure. Like, as I said earlier, I don't know whether maths is the thing for me or is it theoretical computer science or what exactly I'm going to go into. But one thing that I definitely do feel very strongly is that I want to bring some sort of positive impact in the world through whatever I do. And I expect that will be something like maths and computer science for sure.
Not physics?
Maybe physics too, honestly. I do like physics a lot as well. So I'm trying not to close down options.
How about statistics?
No, not statistics.
Not
I don't like statistics.
That's not maths.
No, I don't think statistics is maths. But maybe things will change. So I think one thing that does interest me a lot is this sort of research in theoretical computer science, something like cryptography or something, because I was a part of this camp, Math Beyond Limits, and there we got to experience some of these interesting topics. And I think that's something that really stood out to me.
Have you read the book by Don Knuth?
No, I have not done that once. That's something I'm really trying to.
It's called The Art of Computer Programming.
I see.
Right, and they have, I think, in one of the volumes is only about sorting numbers.
Wow.
Like 40 or 50 methods to sort numbers.
That makes sense.
And Don Knuth is the one who was behind TeX and LaTeX. Actually, TeX, which evolved into LaTeX, which we used to write books. Wonderful. Rushil, what is your advice to young maths aspirants who are probably in class 5 or class 6? If they're interested in mathematics, if they're passionate about mathematics, how can they aspire to compete and succeed at the International Mathematical Olympiad and achieve success like you have done?
Yeah, I think there are 2 parts to this. The first part is, why should you be excited about mathematics? I think that's also a very interesting question. And my sort of feeling about mathematics is that more than anything, it's sort of an art of thinking, an art of problem solving, an art of innovation, which will come in handy no matter what you choose to do. It's just something that is really about this. Everyone thinks that maths is about logical thinking, analytical thinking. But what I think is that it's about creativity, about problem solving and imagination, about innovation. I think those are the things that are really important, and those are the reasons I think maths, if everyone really understands and enjoys, it could have a very big positive impact on the world. Now about if you do enjoy it, I think it's very important that it's recognized early and that you take the right sort of resources for it at the right stage. And I think for this, there are a lot of online resources available. There's this website called The Art of Problem Solving, where there are problems available from like all countries over all years.
Is it only mathematical problems?
Yeah, it's mostly mathematical problems. There's some physics problems here and there, but it's mostly about math. So that's something that you ask any Olympian and they'll know. AOPS. So that's something that's definitely a very big resource. Apart from this, I think it's useful to...
Are there any YouTube channels which our students can
yeah, it
watch
really
videos on?
depends on like what sort of level you've reached. At the very basic level, there are a lot of different courses that are run for IOQM. But I think really it gets interesting when you start seeing stuff for regional math Olympiad, etc., because those are the proof-based ones. So I think there, in fact, Online Math Club itself is a very good channel which has over like 500, I don't know the exact number, but there are lots and lots of classes.
The online math channel, you said?
Yes.
All right, I'll check it out. I watch only Number File and Mathologic.
Yeah, Number File I think is also really good. This thing which really can help you build this sort of excitement and interest in math. And for that matter, I think I also really enjoy Veritasium.
Veritasium, that's more science,
yeah,
right?
That's more science, but... Yeah.
Yes.
Yeah.
How about Kurz gesagt?
No, I've not heard of that.
It's a German channel. Kurz gesagt means a short tail.
I see.
So they are more about science, but the animations are lovely.
Wow.
World class.
Yeah. Yeah, animations remind me of 3 Blue, 1 Brown.
Right. And there's also Physics School, right? Yes. Great channels. Amazing. Outside of mathematics, what do you do? And I prefer if you answer this in Hindi. I'm sure I know you said you're more comfortable in English, but for our viewers जो हिंदी में सुनना चाहते हैं आपको, उनको बताइए आप गणित के बाहर आप क्या करते हैं, क्या आपको अच्छा लगता है, और आपने क्या-क्या और गणित के से इतर किया है?
Actually 2-3 साल पहले तक मैं ये भी नहीं कहूँगा कि गणित was like the only thing I used to do, कि मतलब गणित के अलावा भी मेरी बहुत सारी चीज़ें थी. Now I think थोड़ा सा और restricted हो गया है, maths has taken the priority. पर I have done a lot of things over my middle school. मैंने debates और elocutions में बहुत part लिया था. I used to really taking part in.
आप संगीत में भी आपकी रुचि है, आप पियानो बजाते हैं?
Okay, yes. I used to love playing the piano. Piano मैंने actually lockdown में सीखा था और mostly self-learned था. So if you go to a professional piano person, he will start vomiting at how I play the piano. But I play the right keys.
आप chord बजा लेते हैं?
हाँ, I mean I play well.
दोनों हाथों से?
हाँ जी.
अच्छा.
पर बस उन्हें ये लगेगा कि ये वाला फिंगर से क्यों बजाया, इससे क्यों नहीं, because I've never taken professional tutoring, but I can.
तो आप किसको बजाते हैं जब पियानो पे आप प्ले करते हैं, किस म्यूजिशियन के कंपोजिशन?
I like Yeruma, for example. There's a song called River Flows in You. I also like Ludovico Einaudi is one other composer. Some more well-known songs I think like Pehla Nasha or something I can play.
अच्छा.
और chess is also
शतरंज
something.
चेस खेलते हैं?
शतरंज मैं काफी खेलता हूँ. I think that I've been playing since first grade.
अच्छा.
और I mean थोड़े से ups and downs थे, कभी इंटरेस्ट बना कभी इंटरेस्ट नहीं बना.
आपने ये मूवी देखी है शतरंज के खिलाड़ी? सत्यजीत रे? नहीं, बहुत पुरानी है, बहुत अच्छी. शतरंज पर ही
सुना है पर मैंने देखी नहीं.
प्रेमचंद की एक पुस्तक है शतरंज के खिलाड़ी. शतरंज की बाजी उन्होंने लिखी थी, फिर शतरंज के खिलाड़ी, और उस पर सत्यजीत रे ने ये चलचित्र बनाया था. बहुत बढ़िया है, बहुत उत्कृष्ट है. कभी आपको समय मिले तो देखिएगा. वंडरफुल पीस ऑफ आर्ट ऑन अ ग्रेट बुक. सो व्हाट एल्स रुशिल? और क्या? चतुरंग, संगीत, और क्या? मूवीज देखते हैं आप?
Movies, I've been addicted to movies in the past.
कौन सी अच्छी लगती है आपको?
मुझे Mission Impossible movies से काफी interested था मैं उनमें. और I mean, if you go to the Math Olympiad people, there are very few movies they would know which, like, I mean, go to anyone and like go to any movie, there's high probability that I would have watched it. So I was like the movie man or something.
अच्छा. कुछ खेलते हैं आप?
Yeah, I like playing cricket.
Uh-huh.
I've not played in some time now, but I used to play a lot.
Acha.
I also like playing badminton. But yeah, in the last 2 years, I've not played much.
Okay, that's fair enough. You've worked at the International Mathematical Olympiad. You've authored a book, so that's okay. I'm sure at Oxford you'll pick up a sport and you'll win more laurels in your life and make all of us proud. This is your first book. I'm sure you'll author many more, and we will keep hearing from you. And one day, welcome you again on our show. Thanks a lot, Rushil. थैंक यू व्यूअर्स। तो ये थे रुशिल माथुर, जिन्होंने अंतर्राष्ट्रीय गणित ओलंपियाड में अभी भारत के लिए स्वर्ण पदक जीता है, और आज इनसे हमने बातचीत की। फिर एक कोश सत्र पे आप सभी दर्शकों से भेंट होगी। आई सी ऑल ऑफ यू इन अनदर पॉडकास्ट। टिल देन, नमो।